Chapter 6, The First Awakening Fibonacci. Fibonacci is one of the most intelligent mathematician during 12th century, and so 3 homework assignments are from his books. The first one, number 2. This problem is from one of his book, which is mostly devoted to arithmetic and elementary algebra questions. So this question can be solved by using algebra very easily. If we assume the money he had at the beginning is X denarii, and then we can set up a linear equation and solve the equation for x. So how to set up the equation? We can just kind of translate the English sentence to mathematical symbols using x in there. So for example, he had a x denarii at the beginning, so he double his money. That means you would double x and then spend 12 denarii and then subtract 12 and so on. So that's how to do the first one. The second one is from his other book. This is algebraic identity. It's like a formula. It has, in fact, it has 2 problems, 2 formulas. The left side is only one: a squared plus b squared times c squared plus d squared. This is equal to both of them. AC plus BD squared plus AD minus BC squared, and also it's equal to AD plus BC squared plus AC minus BD squared. First of all, we need to establish this identity. What we do is to use the for rule to multiply out each side. So for example, the left side we can multiply first, and the inside, outside, and the last. And then for the middle part here, we can do the same thing for square. Be careful when we do square, we have to write it as AC plus BD times AC plus BD, and then use for rule. Or if you memorize the formula for square, you can use the formula directly. That's the square of the first term plus twice of the first times second, and plus the square of the second term. But if you haven't, you can still use the for rule, but just remember to expand it as AC plus BD times itself. Similarly, do the same for AD minus BC. So after we multiply both out, we should, after we combine like terms and everything, we should find out that the simplified form of the first one is equal to the middle one. And also do the same to the third one. Multiply out this one, and they should all equal to each other. So first establish the formula. Now we can use the formula. How to use the formula to solve this question? Express the integer 481 as the sum of 2 squares in 2 different ways. So what we want to do is break 481 as some number squared plus another number squared, and we want to find these 2 numbers. If we notice here in the formula that we had the middle part and the third part is exactly the sum of 2 squares, something squared plus something squared, something squared plus something squared. So if we can use what's given here, 481 can be factored as 13 times 37. So if we think of a squared plus b squared as 13 and c squared plus d squared as 37, and it's exact 13 times 37. So kind of like identify the first expression in the parentheses as 13, second one as 37. So it's let me write this down here. So we have a squared plus b squared equals 13, and c squared plus d squared is 37. and try to find out A and B. So it's going to be very easy to break 13 as a number squared plus another number squared. Just try the numbers like 1 and 2 and 3. We should be able to find out. And similarly, break down 37 as c squared plus d squared, two numbers squared. And then we use these two expressions, we can find out A, B, C, D. And then we're going to plug A, B, C, D into the second and the third expression. So AC plus BD is going to be the first number we try to find, and so something squared plus an AD minus BC is another number. And then different way than use the third part. So that's how we do solve number 8. The last problem, number 3, on page 292 is about a Fibonacci sequence, and this is a very famous sequence. There's a video posted on Blackboard. You can maybe, if you're interested in the sequence, it has actually many applications in real life. So what is Fibonacci sequence? We can look at this example here. The first month, suppose first month we have talking about rabbits, or raising rabbits. So first month we have adult pairs 1 and young pairs 1. So it's like we have one pair of parents and one pair of babies. So total we have 2 pairs. So that's the first month. I guess we can consider that the first number is 1, the second number is 1, and then the third number is 2. That's like 2 pairs. So, and then the second month we have two pairs, one adult pair, one young pair. And then suppose the adult pair gave birth to one young pair. Then altogether in the second month we have 3 pairs. And the third month 3 pairs, then we have 2 adult pairs, because suppose it took a month for the young pair to grow to become adult pair. So then these 2 pairs of adult pairs, adults will give birth to young pairs, 2. So we have 2, and then together we have 5 pairs. It's kind of like that. So by the keep going like this, it's kind of like if 1, 1, 2, 3, we can always add the previous 2 numbers. So first month, suppose it's a little, sometimes it's going to be a little bit different, like this. If we think the first month we have one adult pair, and second month they have the first month 1 and the second and 1 adult and then 1 young pair, and the total is 2. So we're adding the first 2 numbers to get the third number, and then we add the previous 2. 1 plus 2 we get 3, and then we add 2 and 3, then we get 5, and 3 and 5 we get 8. I'm missing a number here. And 5 and 8 we get 13, and 8 plus 13 we get 21, and so on. So that's a list of Fibonacci sequence, the numbers. In the homework we were asked to break down the number 100. There are 4 numbers, but you just need to do one of them. Break down 100 as the sum of the Fibonacci sequence numbers. So it's similar to one of the questions in last homework assignment. Break down a number as the sum of the triangular numbers. So in the textbook they have F1, F2, and so on. So F1 represents the first number in the sequence, called F1, and the second number F2, third number F3, fourth number F4, and so on. It has been established that each positive integer it can be represented as the sum of Fibonacci numbers. So we don't repeat numbers. We don't take two numbers twice, but this has been proved, so we don't need you to prove it. We can just try to find some numbers from the list and express 100 as the sum of these numbers.